Right, so we got 4 links, but not all 4 links are actively used. Whenever you ping from right to left or left to right, see, I'm going to ping the other side 10.0.0.2. It's pinging right now. The reachability is there, but the reachability is only through the first link. Now what will happen if the first link goes down? Let me show you. Say I'm pinging -t. -t should be in the front. Alright, this is keep on pinging. As it is pinging, what I'm going to do is I'm going to cut the wire. You see what happens. When I cut the wire, it is going to pick the other link. Out of these 3 links, another link will become active. By the time it becomes active, see how many packets you lose. 1, 2 packets lost. 3. 4. 5. See, 5 packets you lost, and then it took the another link. You saw me disconnecting one wire. Look at this, 01 is missing because I disconnected. Previously 01 was forwarding, now 02 is forwarding. All the other 2 are blocking. Now I'm going to connect the wire back. Now again you will lose some packets. You see, again you will lose some packets because it has to switch back to the old cable. What do we see here? We have redundancy, but it is very slow. And not all the links are actively used. But when you do bundling, even if one link goes down, there are other links to take your traffic, so you will not face this drop. So let us do bundling. You remember, for bundling we have 2 protocols, LACP and PAGP. Link aggregation control protocol, port aggregation protocol. So I'm going to bundle these 4 by using active. Active means what I'm using? I'm using LACP. So command is this: interface range f0/1-4, which means I'm inside all these 4 interfaces, and I say channel group ID 1. This number is to identify the bundle, the logical link, the virtual link that you create. The virtual link that you create is identified with this number. And mode I want is, you see, on mode means manually you turn on, active means LACP, passive means LACP, auto means PAGP, desirable means PAGP. So can you have active on both sides? Can we have active on both sides? Yes, no. Yes is the answer. Can we have auto on both sides? No. Can we have desirable on both sides? Yes. Can you have active one side, passive other side? Yes. Can we have passive on both sides? No. These things we discussed in the previous class. If you are not aware of this, if you are confused, you need to go through the previous video. Now I'm going to say active here. Done. Now if you see here, show interface brief, show IP interface brief, you will see a logical interface called port channel 1 created, but it is down right now. The reason is, on the other side we have not configured port channel, and the identifier I used is 1. When I configured Etherchannel, I said what? Etherchannel 1. You saw that, right? Etherchannel channel group ID 1 I said. So it creates the port number 1, logical port 1. You need to give the same ID on the other side. Interface range F 0/1-4 channel group 1, same number 1, mode active. See, this need not to match on the other side, but this mode this channel group should match. Mode one side active, one side passive is also okay, both side active is also okay. See, now the port channel interface has come up. Now you go back to the previous switch. Previously it was down, but now it is up. Now it is up. So port channel is up. Port channel is up. I'm waiting for these ports to turn green now. Now you will see all ports are green. All ports are forwarding. See, this is becoming green. Now this also will become green. All this 4 will become green. Means they are ready to forward. Previously on switch 2, so on switch 1, only 1 was forwarding, but now show spanning tree, you have only 1 logical interface instead of 4 physical interface. And previously the cost on each link was 19, but now the cost is reduced to 7. Because you got more bandwidth, cost will be less. And it's not a point-to-point link, it is a shared link. Let's wait for the other switch. Still, it is coming up. It will come up anytime. Go again. Show spanning tree. Okay, it is still in learning state. So what I'm seeing is instead of 4 link, I'm seeing just 1 link. It is in listening state, learning state. It should become forwarding state anytime. Okay, it is in forwarding state. See, all are green now. None of the ports are blocking. Now, you see this ping that is happening on the PC? The ping is going successfully on the shared link. What will happen if I cut one wire? Still the ping should go. If I cut one wire also the ping should go. Why? You got the other 3 links to share. So I am going to cut one of the wire. Any one randomly. Tack. I cut, I think, port number 1. You see, I cut port number 1. It has gone down. And now, but still the port channel is there and the ping is happening. There is no drop. Still the ping is going on. I put the wire back. Right, now this will immediately join the group after it listens and learns. Show spanning tree. Okay. Meanwhile, let's go and check whether the ping is going on. Yeah, ping is going on. Nothing went wrong. No packet dropped. Ping is keep on. It's going. It's going. So this will turn green in few minutes. And one more thing, I want to show you the verification commands. Show Etherchannnel summary. This shows that the Etherchannnel that you are seeing is layer 2. Means capital S means what? Layer 2. If you see R means layer 3. You are not seeing R here. You are seeing yes. It's a layer 2. It's a layer 2 Etherchannnel. Capital U means it is right now in use. It is not down. It is in use. If you have D, then it is down. And what protocol is enabled? LACP is enabled. But you didn't mention anywhere LACP. But you do say active. Because you said active, it is LACP. And all 4 ports are having capital P. What is capital P? It is in port channel. It is a member of port channel. They are all member of port channel. You should not see S. If you see S here, means they are suspended, not in port channel. Alright, you should see P only. S means not good. Right? So we can see here, this is again going green. It is red now. Give some time, it will become green. It's packet tracer, problem. But good news is it is still in use. It's not saying, but ping may not be happening now. It's all because of STP confusion. It's not because of Etherchannel. Etherchannel is good. So bundling is already done. Spanning tree is good. There is another command called show Etherchannel port channel 1. Port channel. Okay, simply port channel, not port channel 1. Simply port channel. This also shows a similar output, but in a different table. It says port channel 1 has got 4 number of ports. As of now, it has got 4 number of ports. And the protocol is LACP. And all 4 links are active. F012, F0. The command that we typed is show Etherchannel port channel. Alright. So next is, if you see the load balancing algorithm, the default load balancing algorithm is source MAC address. Where it is. You will see in the other command, the previous command. The previous command was show Etherchannel summary. This will show you that load balancing is okay. There is also a specific command. It's not in the summary. Load balance command. It says I am doing load balancing based on the MAC address. What MAC address? Source MAC address. But if you wish to do load balancing based on the destination MAC address, you can do it. Or source as well as destination MAC address, you can do it. What is the command? See, right now it is source MAC address. We are going to change this. Go to global mode and say port channel load balance. See, you have this many options. The default is this one, source MAC address. If you want to use destination MAC address, you can say, or source and destination MAC address, you can say, or based on source and destination IP address, you can say this for layer 3 Etherchannel. So I'm going to say what source and destination MAC address, both. So now let's go and verify. Show Etherchannel load balance. See, right now it says source and destination MAC address. Previously it was only based on source MAC address. Any question?